Central tendency means exactly what it says. It looks for where the data tend to be centralized, where we see the most occurrence. It's really a fancy way of saying average. And an average is a good shorthand way of collapsing a distribution to a single number. An average, at core, is a measure of a midpoint. But be careful with the word average. It's not very precise. There are actually three distinct types of averages. Usually when we say average, we're talking about the mean. The mean is the sum of all the values divided by the total number of cases. But average could also refer to the median. The median is the middle attribute in the ranked distribution of observed attributes. In other words, half of all values are going to be higher than the median, and half are going to be lower. And we can also think of average as mode. Mode is simply the most frequently occurring value. So, when do you use them? Well, mode is really only useful for nominal and ordinal data. And for nominal data, mode is really the only type of average that makes any sense. Mean and median assume the values are at least rankable, and nominal data, by definition, are not ranked. Ordinal data can be represented by mode or by median. In ordinal data, sometimes simply knowing the most selected value is enough. Sometimes you may also want to know what the middle value is, and sometimes you might want to know both. When we get to continuous variables, we will want to use both mean and median. These two values together also tell us something about a variable's distribution. If the two values are very close, the distribution is fairly normal. If the mean is much higher than the median, then the distribution is skewed to the right. And if the mean is much lower than the median, then the distribution is skewed to the left. This is because the mean is very susceptible to extreme values. So both tell us something useful about the midpoint of a continuous distribution. Now, what do these values not tell us? Well, they don't tell us much about how overall spread out the distribution is. And this is called dispersion. And there are several different metrics to help us understand dispersion. Also, for the most part, these really only apply to continuous variables. Range refers to the distance separating the highest and lowest values. It's often represented as a set, the minimum and the maximum, but it could also be expressed as the difference between those values. The standard deviation is another way of understanding how spread out a distribution is. It is almost always paired with the mean, especially if the median isn't given. It is calculated such that 68% of the cases lie within plus or minus 1 standard deviation of the mean, and 95% lie within plus or minus 2 standard deviations of the mean, and further, 99.9% lie within plus or minus 3 standard deviations of the mean. Not to be left out, the median also has a trusty sidekick, the interquartile range. The interquartile range is the range of scores for the middle 50% of a sample. Like the range, it is often expressed by two numbers, the first and third quartiles. It can also be given as a single number, the value of the difference between these two. And if you're wondering about the second quartile, well, that's the median. To understand quartiles, it might make sense to back up and explain percentiles. A percentile is a score below which a given percentage of values falls. Recall that the median is the value at which half the sample falls below in ranked order. This means that the median is the same thing as the 50th percentile. It's the halfway point. So what's half of half? Well, a quarter, and thus the name quartile. And a quarter is 25%. So the first quartile is the same as the 25th percentile. And the third quartile is the same as the 75th percentile. The first quartile, then, is the value at which 1/4, or 25%, of the values fall below. And the third quartile is the value at which 3/4, or 75%, of the values fall below. And by extension, we can calculate any percentile we want. It is not uncommon in distribution tables to show the 10th and 90th percentiles. They help us to see numerically how skewed a distribution may be. If you are starting to feel a little overwhelmed with numbers, hang tight. Unlike a more traditional stats course, we're not going to go into the equations behind all of this. I have long thought that was just too much for most undergraduates. Plus, we have magic computer boxes that do all of the heavy number crunching for us now. This will all start to make a lot more sense when you get to practice it. So head over to the next video to see how to do all of this in R.